right, let's name some compounds together. In this practice on page 5, a condensed formula is given to you and you're supposed to name it. Let's find out, I mean, it's easier to change it to a skeletal structure. So let's start with the carbon that apparently is carrying some branches. You remember CH3 means the branches. So let's change it to C, and then you see 3 CH3 out of it, correct? Then CH2, and then a CH, which is connected to 2 CH2 CH3, correct? So this is this carbon, then you have a CH2, second one, then the third one a CH. You don't see the hydrogens, right? Hydrogens are invisible. And then CH2, CH3 attached. All right, so let's find the longest chain and name it. As I see, let's try 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it seems like the longest chain contains 6 carbons. If I number from right to left, I mean left to right is 3, 4, 5, and 6. So 2 methyl groups will be on the second carbon. If I number from right to left, then the ethyl group is on the third carbon. So which one is preferred? The one that reaches 2 methyl groups faster. But don't forget, in naming, you are supposed to write the name of ethyl group first, because ethyl, E, comes alphabetically before methyl. So, where is the ethyl group? For ethyl. The methyl groups, how many do we have? 2, and both of them are the second carbons, so 2 and 2. When you have 2, what would be the prefix? Dimethyl, and don't forget I have put dash between every letter and number. And 6 carbon is hexane. D. You number the longest chain. Here, longest chain is not the straight chain. So you have 1, 2, 3. You can try different options and you will see that this is the longest chain. 4, 5, 6, 7, 8, 9, and 10. So it's a decane. Let's determine the branches. Here is a methyl group, here is an ethyl group, a methyl group, and this one is what? A sec-butyl, right? So, sec-butyl, we said sec is a prefix, so we go with B. Here you have a methyl, another methyl, and ethyl. So which one comes first? B, E, or N? B. Where is it at? On 5. 5, sec-butyl. Again, sec is the prefix, so it's not a part of the actual name. Sec-butyl. Then you have an ethyl on the third one, 3 ethyl. Where are the methyl groups? On 2 and 7. 2 and 7, dimethyl decane. Okay, by now you should have learned how to name the straight chain alkanes. But how about the cycloalkanes? And what if you have cyclic alkanes? What to do? Cycloalkanes. Naming cycloalkanes with without any branch is extremely easy. If you have, it's not a very good looking structure. All right. So if you have 6 carbons and you had a straight chain, you would just have called it hexane, right? But this is cyclic, so you call it cyclohexane. Or when you have 5 carbons in a cyclic form, if you had a straight chain, you would name it pentane. But now it's cyclic, so it's called cyclopentane. That's it, easy. Cyclopropane, cyclobutane, cyclohexane, cyclopentane, cycloheptane. But what if you have the branches? What if you are supposed to draw 1 ethyl, 2 methyl, cyclopropane? Again, you're going from name to the structure, so look at the end of the name. It's a cyclopropane. Cyclopropane looks like a triangle. For cyclopropane, you don't have that many choices, so let's just work on the branches. 1, let's call it 1, let's call it 2, let's call it 3. This ethyl, and the second one has methyl. That's it. We're working on page 6. Let's work on the practice 1 and let's work on C. 1 and 2 dimethyl cyclohexane. So put your cyclohexane, again go from the end. And you have 2 methyl groups on the first and the second carbon, so you have methyl, methyl. Working on D, 1 isopropyl, methyl cyclobutane. So drawing the cyclic compounds is not difficult. It's a butane, 4 carbons, so it looks like a square. The first one gets isopropyl. Isopropyl looks like a V on a stem. So this is isopropyl, and methyl group sticks out of the second carbon. That's it. If you want to work on some of the examples of page 7, let's see. The first practice, let me work on C and E. First, C. So we have to first determine the branches. What is the name of this branch? 1, 2, 3, 4 carbons, and just from the end. So it's just a simple butyl. And what is this branch? Methyl. So you start numbering from the one that starts alphabetically first. So 1, 2, 3, 4. And doesn't matter if you go clockwise or counterclockwise, either way, the second carbon will have number 4. So you have 1 butyl, 4 methyl, and how many carbons do you have in your ring? 6. Cyclohexane. Work on D and then E. Those are, to me, the more complicated ones. So, so let's see what is this branch. This branch, 1, 2, 3, and 4. Again, don't count this because this is part of cyclohexane. 1, 2, 3, and 4, but is the first one connected? Does it look like this? No, not for sure. A secondary carbon is connected, so it's the sec-butyl. And this one, you have the V on the stem. So this is isopropyl. In order to name, do I consider sec? No, I go with B. Do I consider iso? Yes, because it is a part of the name. So which one comes first for D? Sec-butyl. I number the ring in a way that the first branch gets the first number, and I do it clockwise. I continue clockwise because I want the second carbon get the minimum number. So it's going to be 1 sec-butyl, 2 isopropyl, cyclohexane. Okay? And finally E, which is different from the other ones, and I'm so glad you have it here to learn something new, is so far our ring, the cyclic compound, was the parent name. Got like cyclohexane, cycloheptane, cyclopentane. But here, look at this. How many carbons do you have in your ring? 1, 2, and 3. How many carbons do you have in your chain? 1, 2, 3, 4, 5. Learn a new rule. If branch has more carbons than ring, then ring will be named as branch. So look how I name it. A cyclopropane is attached to which carbon? We numbered the carbons closer to the branch, right? So 1, what is on 1? If I'm naming the ring as a branch, so it's not cyclopropane anymore. It's cyclopropyl, and this part is the parent chain, cyclopropyl pentane. So you see, you need to compare. If your branch, if the straight chain has more carbons than the ring will act as a branch. But if ring has more carbons than the chain, then the chain is going to be your branch. So whichever has more carbons, it will act as your parent hydrocarbon. All right? Very good. We are done with naming compounds. In the next video, we are going to work on the conformation of alkanes. Make sure you know all the names and the structures well. We are going to start on a little bit of stereochemical point of view on the alkanes.